So you can either, like I said, multiply or divide both sides by -1.
Okay, so we're not just taking what's in parentheses, we're taking the whole,
Yep, this time we're taking
The whole
yep, the whole thing.
and we're replacing the whole cosine.
Yep, we're replacing the whole cosine.
Is there a reason why, when do we know we have to do that?
Oh, whenever you see a cosine and a sine up there,
Mhm.
then that's when you know you have to do that. Because if you saw just before when we had, what was it, cosine of t to the 5th or t to the 8th,
Then you would take what's inside.
yep, then you just take what's inside. But whenever you see more than one trig function, that's when you want to make one of them equal to u. And whichever one is raised to the highest exponent, that's the one you're going to
So you
make.
take the highest exponent one.
Yep, that's
So
the one
let's
you're
say
going to
it
make
was
u.
like cosine 4 to t and then sine 5 to t. You would take sine 5 to t?
Well, when you have, with that one, it's actually, you would cover that in Calc 2. Because it's a different set of rules when you have, in this case, you're always going to have one that's going to equal sine of t or just cosine of t. When you have them going up to different exponents each, that's when you have different rules.
Okay.
So it's like a whole new set of stipulations and stuff that, for that situation.
So, so would that be basically u to the 4th power?
Mm-hmm.
Okay.
Yeah. So you have your 17 times the integral, and instead of cosine to the 4th, just cosine of t to the 4th times sine of t with respect to t. And that gave us our u to the 4th. And this gave us our negative du. With that negative, we can just bring that right out to the front. So you have negative 17 times the integral of u to the 4th du. Okay. And that will become negative 17 times u to the 5th over 5 plus c. Okay, we can bring that 5 right on out. So we have negative 17 over 5 times u to the 5th plus c. And then we just replace our u. Okay, so that gives us negative 17 over 5 times cosine to the 5th of t plus c. All right, so whenever you see more than one trig function up there, then you know you're going to have to make one of them equal u.
And it's always the higher.
Yep, it's always the highest one, or the one that's not 1.
And
Mhm.
why shouldn't we divide the sine t out? Why did you choose not to divide it? Like you divided the 3 on the previous question?
Oh, the sine t, because it's a function of t.
It's the function of t?
Yep. So if you have a function of t, you can't factor it out. You can factor out a constant.
Okay.
Yep, but you just can't factor out like the sine or the cosine.
All right, that makes sense.
Mm-hmm.
Why can't you just take the derivative of sine of t? Or antiderivative, sorry.
Oh, because you're thinking of, at least I'm thinking you're thinking of the rule where you can, if you're adding it, you can kind of distribute the integral. You can't really distribute it with
With both.
multiplication.
Uh,
So let me see.
I think I see, yeah.
Yep. So if you have the integral of f of x plus g of x,
Then you can do it separately.
yep, you can integrate both of them.
And in this case, we can't because that would be, because it's
Multiplication.
right.
Yep, so it's
which is
multiplication.
like a whole different ballgame of like power more and whatnot.
Exactly. So you couldn't, where if you have multiplication with derivatives, you can just use the power rule or the quotient rule or anything like that, but you can't do that with integrals. It's a little bit different.
Yeah, there's no necessary rule for it.
Exactly. Yep, so there's no set procedure for doing that.
There you go. Be famous, make more.
Okay?
I'm just kidding.
I think right now you have people at MIT and Harvard and everything else working on those, and they're losing sleep.
One thing I don't understand is how mathematicians become famous and do all that, and it's like, but it doesn't really have that much practicality.
Well, it does, but
I
in
mean,
like
in
if you
something
go
like
into
this.
like high finance and projections and everything else, it actually has a use.
I've never seen any use for any type of trig function, like sine, cosine.
Yeah, you can. There's actually plenty of uses for them.
Oh, yeah.
More uses for trig than probably anything else below it, but it's useful.
Yeah. It's like practicality, I guess, in theory.
And most things you learn, you're not gonna use out there.
Oh yeah.
It's just.
All right. Okay, so for example, what is the value of the integral from pi over 2 to pi of 3 cosine of t times sine 5 of t with respect to t? Okay. So with this one, our sine has the highest exponent. So that means we're going to let u equal sine of t. Yep, so your du, yep, cosine of t dt. All right, so we rewrite it and just bring that 3, that constant, right on out. And I'm just going to go ahead and switch those around just because. Oh, actually, let me rewrite it. Say sine of t to the 5th power times cosine of t with respect to t. Okay, so our sine of t, that would give us u to the 5th power. And this is our du, and we don't have to divide or multiply by anything. It just evenly came out to du. Okay, so we have the integral from pi over 2 to pi of u to the 5th du. Excuse me. Okay, so once we do that, we just go ahead and use the regular ordinary power rule. Okay, so that's going to be u to the 6th. Oh, did I leave? Forgot my 3. Yep, so let me, I forgot something. That should be 3 times that. Okay, so that's 3 times u to the 6 over 6. Plus c. Bring that 6 right on out. So you have 3 over 6 times u to the 6. Oh, plus c, that's right. It's, I always forget that until I'm getting ready to do it.
You would do the.
Yep, that's pi over 2 to pi.
Yeah, that's what I meant.
Yep. Okay. Now remember, replace u before substituting.
Because this is still respect to t.
Exactly. This is t equals pi over 2 and t equals pi. Okay, so that means we have to have our, that just becomes 1/2. And instead of u to the 6th, that's sine of t to the 6th. From pi over 2 to pi. Okay, so now you can plug them in. Okay, so you have 1/2. So you have sine pi to the 6th power minus sine of pi over 2 to the 6th power. Uh-oh, wrong there. Okay, so sine of pi is 0, so that disappears. And sine of pi over 2 is 1.
Which equals 1.
Yep, so you have 1/2 minus 1, so you have -1, which is -1/2. So you're going to see this message every time we do a definite integral. And I guarantee you, at least 3 of you will plug in that pi and pi over 2 at that step. I guarantee it. Even if I say it 30 times today, I guarantee somebody will do it. I know because I did it. And so that's why I'm like, somebody's going to do it.
Now you can leave half as a constant, right? So I know
Mhm.
that, okay, so I
Yeah.
know that when you had 3/6, you only did one bracket. That should be in like 2 closed brackets, right?
Oh, you mean oh, you mean for this one?
Yeah.
Oh, you can if you want to.
Okay.
Yeah,
That-
you don't have to. I mainly put, because some people will put, instead of a bracket, they'll just put a straight line and do it that way. It's all in which one you like doing. All right. Yes.
So -1/2 in this context just means that across the interval, majority of the area is below the x-axis. If I'm interpreting this correctly.
Pretty much, if your area would be below the x-axis, you have like 1/2 more
Yeah.
below the x-axis.
Okay.
Here we go. All right, so we'll do one more of these and move up to the others. Okay, so what if we have the integral from pi over 3 to 4 pi over 3, -4 cosine of t sine squared of t with respect to t.
Alright, so u equals sine t.
Yep, you let your u equal your highest exponent. So we'll let u equals sine of t, which means our du is going to equal cosine of t with respect to t. And nothing to factor out, so we're good there. Yep, so we bring that -4 out from pi over 3 to 4 pi over 3. And I just usually switch them around. So sine of t squared times cosine of t with respect to t, which gives us our u squared and our du. Okay, So you have -4 times the integral from pi over 3 to 4 pi over 3 of u squared du, which will become -4 times u to the third over 3.
You can just take it out automatically, right? We don't have to.
Oh yeah, if you just automatically rewrote that as -4 over 3 over here, that would be fine. Okay, plus c.
So what would be plus C, right?
Oh, I don't know why I keep doing that. I think switching between one and the other is making me do that. 4 pi over 3. Okay, so if we bring out the 3, -4 over 3 times u to the third from pi over 3 to 4 pi over 3. Once again, yep, replace u before substituting. Okay, so we have -4 over 3 times u is sine of t, so that's sine of t to the third from pi over 3 to 4 pi over 3. Okay, so we plug in our 4 pi over 3. So we have -4 over, nope, actually, 4 pi over 3. Yep, okay, so I'm good. Okay, so we have -4 pi over 3. That's times sine of 4 pi over 3 cubed. Actually, that should be a parentheses. Don't know why I put the bracket there. Minus sine of pi over 3 cubed. Okay. So sine of 4 pi over 3 is negative square root of 3 over 2. To the third power, minus sine of pi over 3 is positive square root of 3 over 2 to the third power. Okay, which would give us -4 over 3. That would be square root of 3 to the third. So it would be 3 square root of 3, actually -3 square root of 3, over 2 is 4, 4 times 2 is 8, minus 3 square root of 3 over 8, which would give us, that'd be plus negative, so -4 over 3 times -6 square root of 3 over 8. Which would be, actually we can cancel these out and make it a lot easier on ourselves. So that becomes 1, that becomes 2, that becomes 1, and that becomes 2. Oh, and actually these two 2's cancel out. So you end up with positive square root of 3.
Why does it become 1 and 1?
Oh, because we just cancel out. 3 goes into itself one time, 3 goes into 6 twice. 4 goes into itself once, and 4 goes into 8 twice. And then those 2's
And those 2 over 2.
ended up canceling each other out. All right, so any questions on this one? All right.
Are we gonna have these kind of questions where we have to remember the unit circle?
Probably. Probably have a few of them pop up there. You don't remember the triangle to remember all the unit
They
circle?
never taught me a triangle.
Really?
My teacher did it.
Oh.
They just gave us a unit circle and told us to
It's a
memorize
memorizing.
it.
That was it, really?
Yeah.
There's a.
Oh, yeah,
Is
there's
it
a-
like short, long, and then.
Oh no, it's just a triangle.
No, nobody taught us.
Really? All right. If we have time at the end, remind me to show you the triangle.
Alright.
You can remember every value that was on that chart in 2 triangles. All right. Anyone still
Usually the way
writing?
I had to remember it was when she made us remember it, I would actually, you know, you learn
Oh,
how
you
to
mean the
solve them.
Square root of
Based
4
off
and
the
then
degree.
square root of 3, square root of 2, or
I went off the degree and did that, you know, pi over 180 and all that stuff. But, you know,
Okay.
you had to solve it all out. That's
Mm.
why I had to do it because I
Oh,
don't
yeah,
remember how to
that's-
say it. So
that's the long, painful way.
yeah, because that's how I had to do it.
All right, so the integral of 4t to the 4th times e 6t to the 5th with respect to t. And just like before, for this one, our goal is the integral of e to the u du. So that means we have to make our u equal 6t to the 5th. Which means our du is going to equal 30t to the 4th with respect to t. Divide both sides by 30. You have du over 30 equals t to the 4th with respect to t. Okay, so if we go ahead and rewrite our integral, we can just bring our 4 out. So you have 4, and go ahead and switch those around.
E to the U.
Yep, so you have e to the 6t to the 5th times t to the 4th dt, where this gives us our e to the u. Bless you. And this gives us our du over 30. Okay, so that becomes, we can just bring our 30 right out to the front. 4 over 30 times the integral of e to the u du, which just becomes 4 over 30 is 2 over 15. So we can just simplify that. 2 over 15 e to the u plus c. Yep, because remember the integral of e to the u is just e to the u.
I forgot about that.
Okay, so now all we have to do is replace u. And that gives us 2 over 15 e to the 6t to the 5th plus c. Okay. All right, so it's kind of the same process for a lot of them. You pick your u, you find your du, and then you kind of switch stuff around so it all fits. All right, so let's do another one like this. Nope, let's do right. All right, looks like everyone's done. Okay, so let's say this one we'll let the integral from -2 to -1 of 4 times e to the 2t minus 4 with respect to t. And you want to have the exact answer. which means no, you don't have to use decimals or anything.
So
Okay.
E equals, U equals 2t minus 4.
Yep, you want to turn that to e to the u. So we're going to let u equals 2t minus 4, which means our du,
2.
yep, will equal 2 with respect to t. Or du divided by 2 equals our dt. Okay, so if we go ahead and rewrite it, then we go from -2 to -1, bring our 4 out to the front. E to the 2t minus 4 dt, it gives us our e to the u. And this is our du over 2. Okay, so if we rewrite that, we have 4 times the integral of e to the u times du over 2, where we get that 1/2 and bring it out to the front.
Just change that to 2.
Yep, 4 over 2 times e to the u du, which just becomes 2. And the integral of e to the u is just e to the u. So you have 2 e to the u, forgot my -2 to -1. From -2 to -1. So you all know what's going there. Replace before you substitute. Place u before you substitute.
So we would separate the 2 out to the front, right, when we do this? So we'd be like e to the...
Well, if you wanted to do each term and multiply it by 2, you could. I just normally bring it out to the front to keep from rewriting the 2 over and over again. Okay, so that would give you 2 times e to the 2t minus 4 from -2 to -1. So if you wanted, like I said, you could put another bracket on the other side of the e to the u. Okay, so that's just 2. Now we plug in our -1, e to the 2 times -1 minus 4, minus, now we plug in our -2, e to the 2 times -2 minus 4, which would give us 2. -2 minus 4 is -6, minus -4 minus 4 is -8. Okay. And that would be our exact answer. Or you can make it 1 over e to the 6 and minus 1 over e to the 8th.
Could you not use, no, that's only with multiplication.
Oh, you mean combining
Yeah, I
them?
was gonna
Oh,
combine
yeah.
them.
All right. So any questions on this one? All right.
You don't have to turn that into like outline or anything like that.
Oh, no, you don't have to. You only have to do that if you had like natural log of y equals something and then you raise them both, or e to the something, you have to cancel it out. That's the only time you do that. All right, well, I'm just getting ready to shut off in a few seconds.